Okay, gang, here's my next little tidbits for you to finish out the chapter that we didn't quite have time to discuss in class today. You can come in if you want. There are many biologically active halogenated compounds, most prevalent of which, or notable of which, is the one known as thyroxine. Some of you may be familiar with it. It's the thyroid hormone, and it's the one for which you have the need for iodine in your diet to get a proper level of this hormone. It requires iodine on an aromatic ring to form properly. So without that in your diet, you don't have thyroid hormone properly formed, and without it, you get this weird thing called goiter. So it's a very scary condition. Thankfully, we have iodized salt, and that avoids most of our issues with thyroxine deficiencies. If you live too far from the ocean, you don't get your iodine from saltwater fishes. So that's why we have to have iodine in our diets here. In the salt. Other examples of halogenated compounds that are relevant and significantly going to come up in your encounters from time to time are things like dichloromethane, and that's a solvent, and trichloromethane, also known as chloroform. These are both good solvents because they mix well for nonpolar compounds. And these things are used as solvents for nonpolar kinds of compounds. The other important example is one that's got a bad historical story, and that is DDT was used to control malaria, as I mentioned briefly in class, and typhus. It was used as an insecticide, but it accumulated in the food chain and was nearly responsible for the demise of the bald eagle, America's national bird. Thankfully, that has been overcome with time. The problem was the DDT accumulated in things like fish, which ate the insects that were being poisoned with the pesticide. The fish were eaten by the birds, and the birds ended up with soft-shelled eggs, which didn't hatch properly. Chlorofluorocarbons are also halogenated. These are things that are known as freons that have been responsible for some depletion in the ozone, which you may have heard about. However, these have been banned for quite a long time now, since 1980, as propellants and aerosols, and they still are used as refrigerants, but it's not worldwide banned, so there's still some concern there. The trouble with all of these halogenated compounds is that they are not biodegradable. They persist in the environment, and so once they're there, they don't go away anytime soon. Okay. The other examples that I mentioned in class today are halogenated compounds that are ether derivatives that are used as anesthetics now. They're less flammable. That's important. And other than that, you can review the reactions from the chapter about dehydration. Whenever you see an alcohol group and sulfuric acid, that means you're going to lose water. And this reaction looks really wacky because of the way the ring is laid in here. It would be an aromatic ring with an OH here and a methyl group. Oh, I did that wrong. I have to try again. Let's see. The aromatic ring that has a carbon and the OH group here and a methyl group and another carbon here and carbon here. And if I remove that, it will help you to see that when you're selecting where to dehydrate, you're going to pick this OH and a hydrogen from an adjacent carbon. This carbon has 3 hydrogens. The other carbon has 2 hydrogens. You're going to take from the carbon that has the fewest, and the result is that you end up with, I'm making this too crowded, I'll move it over. The carbon over here that had OH still has CH3. It's going to be now double bonded to CH and another CH3. All right, good luck with your studying, and I hope that helps you to summarize a little bit about alkyl halides, and remember to check on your homework to get those done on time, and good luck studying for the test.